Hello and welcome. In this lecture, we will discuss climate change, one of today's biggest challenges. My name is Nina Mahandel, and I will give a brief overview of what's happening now and where we are headed. Understanding climate change is crucial when we talk about sustainability. International experts stress there's a rapidly closing window of opportunity to secure a livable and sustainable future for all. That sounds drastic. So, let's have a closer look at how the climate is changing and how that impacts humans. In this slide, we see a time series of the global average temperature. Observations show that the temperatures are increasing since pre-industrial times, with a particularly fast increase since the 1980s. The red line here indicates a warming of plus 1.5 degrees Celsius. Limiting the warming to 1.5 degrees was set as a goal in the famous Paris Agreement, a legally binding international treaty signed by almost all countries in 2016. Reaching this goal becomes increasingly difficult. We can see that in 2024, the global average warming already passed the 1.5 degrees Celsius line. But not only the air is warming, so are the oceans. Here we can see that the sea surface temperature has been exceptionally warm the last 3 years, compared to the last 40 years, indicated by the grey lines below. What is further concerning is that the warming is happening much faster than predicted. Let's have a look at a few more indicators of climate change. First, on a global scale. In addition to the increase in air temperatures, such indicators include sea level rise, melting of glaciers, or the increase in extreme precipitation. However, some regions on Earth are affected much more strongly than the global average. For example, air temperatures in Europe have increased almost twice as much than the global average. Another example are certain island nations like Tuvalu, which are under threat of becoming uninhabitable by the end of the century due to the sea level rise. And here in the Netherlands, but also other countries, heavy precipitation events have strongly increased. And these are only a few examples in a long list of regional extremes. We know what is causing climate change: human greenhouse gas emissions, especially CO2 emissions. On the left side of the slide, we see a time series of global fossil CO2 emissions. More emissions of CO2 lead to an increase of CO2 in the atmosphere, as we can see on the right side. And more CO2 in the atmosphere leads to a warming of the Earth. While the COVID-19 pandemic led to a brief decrease of CO2 emissions, emissions quickly increased again after 2020. This short-term decrease of CO2 emissions had almost no impact on atmospheric CO2 concentrations due to the long lifetime of CO2. So, how much the Earth continues to warm depends on how much we emit over a longer time span in the future. Here, we can see different projections of future emissions. Considering current policies and pledges, global greenhouse gas emissions will slowly go down, resulting in an expected warming of 2.5 to 2.9 degrees Celsius by the end of the century. A much more drastic reduction is needed to reach 1.5 degrees Celsius goal set by the Paris Agreement that we talked about earlier. We can see the gap between what is currently done and what's the goal is big. But you might say, a warming of 1.5 or 3 degrees, that does not sound like much of a difference. So does it really matter? And the answer is a clear yes. With every tenth of a degree of warming, risks to humans and nature increase significantly. That includes risks for ecosystems and biodiversity, water availability, flooding, especially in coastal areas, heat stress to the human body, and global food production. To summarize, we know that the Earth is warming due to human greenhouse gas emissions. With current policies, we will reach a warming of about 2.7 degrees Celsius compared to pre-industrial levels by the end of the century. To limit the warming, we need to do much more. Greenhouse gas emissions need to be drastically reduced, namely to net zero. This drastic reduction is necessary because risks to humans and nature increase with every tenth of a degree. And that's it for this lecture. See you next time.